In this video, pre-cal students, we will be studying the set of trig identities called double angle identities, okay? Double angle identities. Your heading for today is double angle identities, obviously. The lesson number is 10.5, and be sure to include today's date with your notes if you would, please. Double angle identities, lesson 2.5, and be sure to include today's date, okay? These identities, these double angle identities, will be found on page 657. So feel free to turn your books there if you want to. You don't have to, or you can just copy them off the screen. However, I would like to encourage you to not copy these at this time. I would I would do it later because it is going to take a little bit of time to copy these, and I want to go ahead and jump right into these problems. Okay, so I would encourage you to later on photocopy these or copy these into your trig identity sheets later, okay? But double angle identities simply do this for you. If you'll take a look at these, they take a situation where you have sine of 2 times an angle, or tangent or cosine of 2 times an angle, and it allows you to rewrite it so that you have a trig function with only u, not 2u, okay? So it allows you to take a double angle and rewrite it so it just has a u, or just the angle without the times 2. Okay? And that's what all of these do for you. Here we have 2u, but it's rewritten with u and u. Here we have 2u, and it's rewritten with u or u or u. Now, what does this mean over here? Well, what this means is that you have 3 choices you can make, okay? Cosine of 2u equals this, but it also equals this, and it also equals this. So you can use whichever one of those is more helpful depending on the type of problem that we're dealing with, okay? Okay, hope that makes sense. And let's go ahead and look at very quickly here 4 examples, and then we'll be finished, okay? Here's the first example. I would like us to solve this equation. Now, this equation presents 2 problems. Please copy this down and listen. The first problem is we have a sine and a cosine. Now, normally we like to make a substitution to get rid of one of those so that everything is cosine or everything is sine. Number 2, the second problem is, look, we have cosine of x and sine of 2x. Students, it's always more difficult to solve an equation when you have basically 2 unknowns. You've got an x here and a 2x here. Okay, it's going to be really difficult. So here's what we're going to do. We're going to take sine of 2x, and if you'll look at your chart here, we can make the substitution right here for sine of 2x. Okay, so let's go ahead and do that. I'm going to go ahead and write 2 cosine x plus, and then for sine of 2x, I'm going to go ahead and write 2 sine x cosine x. Now look what that did for me, students. Look at what this does for me. I now, yes, I still have sines and cosines, which can be a problem, but really I can just now factor a cosine, a 2. I can factor a 2 out of both of these and a cosine out of both of these, and I really will be moving right along. That'll be a big help to me, okay? So factor out a 2 cosine x, and you're left with 1 plus 2 sine x. Look at that. And if you want to test that, go ahead and take 2 cosine x and multiply it back through, and you'll see you'll get what we started with, okay? So, in fact, actually you would not. I made a mistake. I'm sorry. So I was testing you. Just kidding. The 2 would not be there. Okay? There we go. And moving on. So now we take each group and set each group equal to 0. So we would have 2 cosine x equals 0, and 1 plus sine x equals 0. Okay? Now divide both sides by 2. Cosine x equals 0. And move the 1 over and make it negative. Sine x equals negative 1. Now, you should understand by now, when you're dealing with cosine and sine, and you're trying to find an angle that gives you 0 or negative 1, you're going to be dealing with axis angles. So quickly with your calculator, if you check 0, 90, 180, 270, you're going to see that x equals 90 and 270. Okay, if you take the cosine of 90, you'll get 0. If you take the cosine of 270, you'll get 0. Over here, the only angle that gives you negative 1 when you take the sine of it is 270. Okay, Now, if you test, remember, whenever your original equation has more than one trig function, in this case we have a cosine and a sine, you must check each answer in the original equation up here, okay? And so if you do that, you will see all of these do work. So there's no need when you write your answer to write 270 twice, okay? So one answer is 90, that's pi over 2. Remember, don't forget to put plus 2 in pi, okay? Whenever there's no domain given in the original problem like this, then you've got to put plus 2 in pi, okay? And then the other answer would be 270, which is 3 pi over 2, plus 2 in pi. So this equation would have been very difficult to solve if we had not been able to use our double angle identity right here, okay? Moving on to number 2. Please take a second and copy this down. I will wait just a minute while you copy this down. Okay, a couple more seconds here. And here we go. Well, first of all, we know the cosine of x is 5/13, okay? And we know what quadrant we're in by this right here. X is between 270 and 360. So we know we're in our fourth quadrant over here. So let's go ahead and draw our triangle. And we know the cosine of x is adjacent over hypotenuse, okay? So there we go, adjacent over hypotenuse. Now, if we go ahead and find the other side, let's see what I don't have it ready. Usually I do. I think it's 12, but I'm probably wrong. 169 minus 25. Yes, it'd be 12. So using Pythagorean's theorem, we see this side over here is 12, okay? Now, remember your signs over here. Negative, positive, negative. Sine, cosine, tangent, okay? Now, look, they want us to find the sine of 2x, correct? Okay, no problem. What is the sine of 2x? Well, we could find it if this was 2x right here, but it's x. So we have the sine of 2x. We better rewrite it using our identities, and we'll get 2 sine x cosine x. So now 2, what is sine of x? We'll come over here to your triangle. Sine of x would be 12/13 negative. So negative 12/13. And what would cosine x be? Well, we already know it's positive 5/13. And now, guys, I'm not going to take time and do this for you. If you use your calculator and type all this in, you would get a negative 120 over 169. So there's your answer. Okay? Not too difficult. Now let's continue on and let's find the cosine of 2x. The cosine of 2x. Now there's 3 different choices you could make, okay? From your double angle list. And I don't really care which one you use. For me, I chose this one for really no certain reason. I just chose to use this one. 2 cosine squared x minus 1. So here we go. 2, and of course we're going to square cosine. So cosine is 5/13 squared and then minus 1. Well, guys, if you square 5/13, you get 25 over 169, okay? Because you square the 5 and square the 13. And then if you take 2 times 25 over 169 minus 1, I'm not going to do all that work for you, but you get negative 119 over 169, okay? So there we go. Not too difficult. Now I want to show you something pretty cool. Watch this. This is so cool, okay? Watch this. You're ready to do your tangent, right? Some of you might have worked ahead, and you're ready to do your tangent of 2x. You're like, okay, tangent of 2x, I'm going to make a substitution. Hold on a second. Tangent of 2x equals, let's use one of our old identities and make this easier. The tangent of 2x equals, remember tangent is sine over cosine, and if I have 2x here, as long as I use 2x here and 2x here, I'm totally fine. Now you say, Mr. Earhart, how's that help? Are you kidding? Look, I know what the sine of 2x is. The sine of 2x equals this, and it equals this, so I put negative 120 over 169. Let me pause and say this. You're welcome to go ahead and go back here and take this tangent identity and use it. That is totally fine. It'll work, okay? But for me, I'm just going to do this. I'm just going to say sine of 2x is 120 over 169. Cosine of 2x is negative 119 over 169. And because tangent of 2x is sine of 2x over cosine of 2x, and now just take your bottom fraction, flip it and multiply it times the top, and you will get positive, because the negative divided by negative is positive, you will get 120 over 119. So there, we did it. We took just this information and this quadrant information, and we found the sine, cosine, and tangent of 2x by using our trig identities. Okay, moving on to number 3. Rewrite sine of 4x in terms of x. Okay, this will be a little tricky, but take some really good notes. I think we'll be okay. First of all, when we say write it in terms of x, we're saying that you want your angle to be just x, not 4x. Now, I have a suggestion for you. I'm going to work going down here. So here, first of all, I'm going to write sine of 4x. Then I'm going to put this. Because I would like to work with a double angle, I'm going to put this. I'm going to put sine of 2 times 2x. Now watch. So this number right here is my 2, and 2x would be your what? Your u. Do you see that okay? Come back here and look at your identities, okay? Sine of 2u equals 2 sine u cosine u. So as long as I have a 2 here, then whatever is next to the 2 will be my u, okay? So this is my 2, and 2x is my u. So now I'm going to write 2 sine, and then I put u. Well, u is 2x, so I'll put 2x. Then cosine of u, well, u is 2x. And I'm doing really well. I mean, I'm not done yet. Remember, I want to have x here and here. Okay, I want to write it in terms of x, but I have 2x, so I'm almost done. Because now for sine of 2x, I can make a substitution. So 2 parentheses, and then sine of 2x, of course, would be 2 sine x cosine x. And then for here, for cosine of 2x, you can make one of 3 choices. I just happen to choose this one. Really no necessary reason, okay? Just trying to use different ones. There we go. I did it. Look at all of my trig functions. Every trig function has an angle that's x. Sine of x, cosine of x, sine of x. So I'm doing great. Now let's simplify, okay? 2 times this whole expression here would be 4 sine x cosine x times 1, if I can write a 1 here, 1 minus 2 sine squared x. And now multiply this through, so this is one term. So take this one term times 1, and this one term times this term. So anything times 1 is just itself. So 4 sine x cosine x times 1 is 4 sine x cosine x, and then 4 sine x cosine x times negative 2 sine squared x would be negative 8 sine cubed, because you have sine times sine squared, and then cosine x. Okay, and that's it. We did it. I'm just checking my answer to make sure I'm right, and we are good. We know we're done because we've written every angle in terms of x. Okay, one more and we're done. One more. Now, as soon as you see this, you're like, well, Mr. Earhart, it's identical to the last problem. What's the big deal? It's really not. Because if you try to write this one with a 2 times a u like this, look what you're going to have. You're going to have 2 times 3 over 2x. And then when you go to rewrite it, you're going to have 3 over 2x. And that's not going to break down well at all. And the last problem, when we did it like this, your u was a 2x. So you could very easily then break down your 2x, sine of 2x, into another trig identity. So this is going to be a little more difficult. So here's my suggestion to you. Let's go back into old school days, okay? Back into the identities we learned earlier. And instead of putting sine of something times something, let's do this. Look at this, guys. If we rewrite it like this, 2x plus x, which is 3x, that's really good. Because look what happens. Now this goes back to your sum and product identities. So you might want to get those out and look at them. Sum and difference. Sorry, your sum and difference identities. And so when you do this, you end up with this right here. This is your u and this is your v, okay? So you would have sine of 2x cosine of x. Well, actually, I'm going to do this to make it really simple for you to see, okay? It'd be sine of u cosine of v plus cosine of u sine of v, okay? Now, for the u, I would put 2x. For the v, I would put x. And for the u, cosine of u, I'll put 2x. And for the v, I'll put x. There we go. Now we're almost done. Remember, all that we wanted to do was write this in terms of x. So now for sine of 2x right here, this right here, I'm going to substitute 2 sine x cosine x. Of course, then that would be times cosine x plus, and then for cosine of 2x, I have many choices. I'm going with this choice. And again, you could choose whatever you wanted. 1 minus 2 sine squared x times sine x. And now let's simplify, students. We're just about done, okay? This is one term here, not two terms. It's one term times cosine x. So you would get 2 sine x cosine squared x. Mr. Earhart, how do you know this is one term right here? Because they're multiplying. If there was a plus sign right here or a minus sign right here, then you would have two terms, but you don't. Okay? Then here we have two terms, so we take our sine times our 1 and our sine times our negative 2 sine squared. So we have plus sine x and then negative 2 sine cubed x. Okay? Now I'm trying to see if there's any like terms here that I can put together. This is pretty much it. I know the book took it a little further, and I'm looking at what they did. I believe that they might have, hold on one second. Okay, students, they took it a little further. This is good enough for me. This is totally sufficient, but real quick, they put for cosine squared here, cosine squared, they put 1 minus sine squared, and then did some more simplifying, and there's no need for that. This is totally sufficient, okay? So there we go. We have taken our original expression, sine of 3x, and we've written the entire thing in terms of x. Sine of x, cosine of x, sine of x, sine of x, okay? All right, I hope this video has been a help to you. Double angle identities, all right?